All right, so this lesson that we're going to do today is on understanding algebraic expressions. Okay, so I just want to remind you an expression is a number sentence without an equal sign. Okay, so if you look at all of these number sentences, there are no equal signs. Okay, an algebraic expression has numbers, operations, and variables. Oops. So remember, a variable is a letter like C, N, D, A, or X that I don't know yet. Those are my unknown values. Okay. We are not trying to solve for the variables today. We actually don't care about what the algebraic expression would represent. We just want to understand algebraic expressions because we need to be able to go back and forth between the word phrase and the expression and understand that difference. So what I need for you to do now, I'm going to pause this video and you're going to take some time, and yes, I know it'll take a little while, that's okay, you need this. You're going to draw this on a piece of paper, and then we will talk about it afterwards. So go ahead and pause the video. All right, so now that we have this written down, now let's go ahead and start talking about what this means. Okay, so when I look at my word phrase over here, what I'm looking for are keywords. Okay, looking for the keywords that tell me what operation I'm dealing with. I'm also looking for numbers and I'm looking for the variable, okay, which is that unknown letter. So when I look down here, $3 more than cost C, I want to separate three parts, okay? So the keywords, I'm looking for that first. More than, okay? Depending on how I use more than should be addition. Now it could be subtraction, depending on how I use the keyword, which is why the other two are so important. Because this says I have $3. I'm starting with $3, okay? But I have $3 more than the cost, which is C. I don't know what the cost is, okay? I don't need to know today, but I know that there's a cost. So I have the cost plus 3 more than that, okay? So that tells me that I need to do 3 plus C, which is addition. Now, remember, the commutative property of addition tells me that 3 plus C is actually the same thing as C plus 3. So it doesn't matter which one of these I use. Now remember, this is not an equation, so I don't want to write it like that. I'm just pointing out that over here, when we said 3 plus C, and then you see it written right here as C plus 3, that's still the same thing. And I realized this went away, so let me draw that in there. Okay. All right, so now we're going to look at this word phrase. So again, I'm looking for the three parts. Okay, I see that there's 12 pencils. I see the word decreased. Decreased is subtraction because it's going down. Decrease is down, increase is up. And I see that the variable is n. Okay, now they're telling me I have 12 pencils. Okay, that's my total. I have 12 pencils and I decrease that by n. So the way we write that is 12 minus n. Because if I tried to do n minus 12, that is not the same thing. Okay, c plus 3 is the same as 3 plus c because of the commutative property of addition. But there is no property of subtraction that says that these are the same. And I can prove that to you if I use a number. Let's say I have the number 3. N is 3. Well, 12 minus 3 would be 9. So this side would be 9. Okay. Over here, I have to use the same number. So let's say that n is still 3. Well, if I do 3 minus 12, that actually gives me negative 9. And that is not the same answer. Okay, so this is not correct. Okay, so you have to pay attention to what comes first. So they're telling us I start with 12 pencils, so that's what has to be first here. All right, so looking here again, I see my number is 5. I see my keyword, oh, well, look at that, times. Well, that's multiplication. And then the variable is d. That's actually a pretty easy one, 5 times d. Now, there's something that I need to stop here and explain to you. So in algebra, one of the things that we try to do is we try not to use the x as the multiplication symbol. Because if I'm using x as my variable and I'm using it as the multiplication symbol, it can get very tricky. Okay, so if I don't have x, I can write it this way, 5xd, meaning 5 times d. Another way, sometimes we use this little dot to represent multiplication. Okay, so if I had x as my variable instead of d, I might write it like that. Okay, but most of the time when we are doing algebra, we have a number that is right next to the variable. It always, 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 always means to multiply the number times that variable. Okay, you'll hear me say that a lot. It does not matter what the number is, it does not matter what the variable is. If they are next to each other and there is no other operation symbol, it is always multiplication. If it's any of the other operations, addition, subtraction, or division, there will absolutely be a symbol. So anytime you see a number next to a variable, it always means to multiply. So then we have this down here. Well, they start off with a variable, a. I have a apples. So I don't know how many apples, but there's a. And look, it actually specifically tells us divide and then by 4. Okay. Now, when I am dividing, normally we say this, a divided by 4. Okay. However, we're going to talk about this after Christmas break when we get into fractions. Okay. Every fraction problem is a division problem. Okay. Because this right here, this fraction symbol is actually another way of saying divide. If you take your division symbol, think about this symbol, and instead of the dot, I put a, and instead of the dot, I put 4. Look at that, a divided by 4. That's why we have this symbol for division, because every fraction is a division problem. Okay, if that doesn't make sense, don't worry about it. You don't need to know that now, but I'm pointing out this is how we will mostly write it, but you might also see a division problem like this. Okay, same thing up here. We might write it this way or write it this way. And so sometimes we have a word phrase like this that actually has 2 operations in it. Okay, we're still looking for our keywords, numbers, and variables. So when I go here, I see the number 5. I see less than, which means minus. I see 3. I see times, which means multiply, and I see the variable of x. Okay, now here's where sometimes it helps to think of a number for the x, okay? Because they're saying I have 5 less than. Well, think about that. Can I start out with 5 less of something? Or do I need to have a total of something and then take 5 away? Okay, so for instance, can I start out a problem with 5 less than an amount? Okay, or do I need to take the 5 away from something else? Okay, so even though they have this 5 less than is here first, notice over here it's actually the second operation. Okay, I can't start off with 5 less than something. I have to be able to take that 5 away from something. So there's where you have to kind of think about your totals and your labels that we've been talking about all year. And then 3 times an amount. Well, that's 3 times x. So they're writing that this way, 3x. Okay, so what they're saying is, I don't know what the x is. I don't know what that amount is. Okay, but that amount times 3 and then take away 5 is what I need to be for this word phrase. Okay. Now, I understand that this is a very difficult concept, and this is something that we're going to have to work on together. Okay. Which is fine. I'm totally prepared for that. All right. Tomorrow, we will take these algebraic expressions and we will plug in numbers for the variables, and so that we can then solve them. Okay, today is not about solving. Today is just about going back and forth from the word phrase to the algebraic expression and understanding how to change those back and forth. So what we're going to do now is I have the word phrase, and now we need to come up with the expression, the algebraic expression that goes with the word phrase. So again, we look for 3 things. Let me get my text here. All right, so we look for keywords, we look for numbers, and we look for variables. Okay, just like what you saw in the last slide. So I see the difference of a number t and 22. Well, difference is subtraction. That's a key word. My number is 22, and my variable is t. Well, remember that if I'm dealing with subtraction, I have to pay attention to what my total is. I have to pay attention to what starts first. So in this sentence, because they have the t first and it's subtraction, then that t has to be first in my algebraic expression. So I would write my t minus 22. And that's my algebraic expression. Okay, going down here. I have M bicycles added to 18 bicycles. Well, my variable is M. My operation is addition. And my number is 18. Well, look at that. There's my algebraic expression. M plus 18. Okay, so if you're looking for these 3 things, it's going to help you out a lot. Same thing down here. I have 11 times, tells me it's multiplication, a number z. There's my variable. So I need to write that. Either I can write 11x as the times symbol, z, or I can write 11z. Because remember, when a number is right next to a variable and there's no other symbol, it always means to multiply. All right, and then that is the same thing if I have a multiple step algebraic expression. Okay, So I start with the number 4, and here I have that less than. This is the same thing as that last one that we saw on the last slide. Okay, remember, I can't start by taking 4 away. Okay, if it says less than, I have to take that 4 away from something. Okay, but I don't have anything in front of that. So this over here actually has to be first. Taking away that 4 has to be the second step. Okay, and just think of it this way: I can't take 4 from nothing. And basically that's what that's saying. Take away 4. Well, I can't take 4 from nothing. I have to take it from here. So then this part has 5 times g. And again, I can write it like this: 5 with a multiplication symbol g. Or I can write 5g, because when a number is next to a variable, it means to multiply. So again, today we are not finding the algebraic expression, we're not simplifying it. All we're doing is changing the word phrase to a algebraic expression.